Good morning everyone. Today we will start numerical practice, okay, of class 12 chapter 1 chemistry, and the chapter name is solution, okay. So one by one we will explain all the numericals, okay. So first numerical, it is calculate the mass percentage of benzene and carbon tetrachloride if 22 gram of benzene dissolved in 122 gram of carbon tetrachloride, okay. So mass percentage, it is given here. First you should know the chemical formula, okay. What is mass percentage? Whatever you want to solve now, that you have to keep upside of that component. So mass of the solute, suppose you want to calculate the mass percentage of benzene, then you have to keep the benzene upside, okay. Then down total mass of the solution into 100. Why we have done this 100? Because it is mass percentage, okay. Of benzene you want to solve, then mass of benzene upside and total mass it is given down. Mass of benzene, what is given here? 22 gram up, and down total mass 22 plus 122, okay. You will keep down, multiply with 100, then you will get the answer. It is 15.28%. But if you want to solve the mass percentage of other component of carbon tetrachloride, this you have taken here. So directly you can use this formula, 100 minus mass percentage of one component, okay. Why you have taken the 100 minus? Because it is the percentage, and percentage always calculating in 100 only, okay. So 100 minus 15.28, it will give the mass percentage of other component, okay. So next numerical, it is calculate the mole fraction of benzene in a solution containing 30% by mass in carbon tetrachloride. Two components present here, benzene and carbon tetrachloride. Now you have to solve the mole fraction. So mole fraction, actually it is represented by X. So whatever component you want to solve, you have to keep that component upside. So mole fraction, it is given, it is not a mass fraction. Then moles of the component upside you will keep, okay, and down moles of the solution, okay. In mass percentage we have kept upside mass and down total mass. So in mole fraction you will keep moles of that component divided by total moles, okay. So this formula it is written here. Next, in this you can see here it is given 30%. So what is the meaning of 30%? By mass of benzene. So which solute present here? It is benzene. 30% by mass. So it means it is present in gram, okay. So 30% by mass means 30 gram of benzene present in 100 gram of solution. So here mass of both component it is given to you. Of benzene you want to solve, then you have to keep benzene upside, okay. So mole fraction, you can solve moles of benzene divided by moles of benzene plus moles of carbon tetrachloride, okay. This is the actual formula. So moles, how you can solve? Given mass by molar mass, okay. So given mass by molar mass of benzene, it is given 30 by 78. 30 it is given, 78 we have calculated already, it is the molar mass of benzene, okay. Now moles of carbon tetrachloride, in the same way you can solve. 30% it is given, then 30 gram of benzene, then remaining part it is 70 gram of carbon tetrachloride. Then upside given mass of carbon tetrachloride and molar mass of carbon tetrachloride, down you have to keep, then you will get the value of moles, okay. Now put these two values, moles of benzene and moles of carbon tetrachloride, up and down, then you will get the answer, okay. So this is the solution. So final answer you will get 0.458, 0.458. Suppose if they will ask from you, also calculate the mole fraction of carbon tetrachloride, then how you can solve, okay. You should know about that. Mole fraction of every component is always equal to 1, okay. So mole fraction of benzene plus mole fraction of carbon tetrachloride, it is equal to 1. If one component mole fraction you know, then other you can solve easily, okay. So 1 minus mole fraction of benzene you will get mole fraction of CCl4. Okay, this is the shortcut, so you can solve by this way also. Next numerical, it is calculate the molarity of each of the following solution. Okay, molarity you have to solve, so you should know the formula of molarity. We have many times discussed. Okay, so molarity, it is equal to moles of the solute divided by volume of solution in liter. Okay, it should be in liter. Okay, and moles, how you can solve? Again, N is equal to given mass by molar mass. Okay, this is only the method to solve the moles. So molarity formula we know already. Moles, how you can solve? Given mass by molar mass. Okay, so moles of this compound, it is given here, cobalt nitrate 6 water molecule, it is given. Okay, actually in exam you will get the molar mass of each element. Okay, by using that you can solve. So it has already solved here. Molar mass of cobalt nitrate 6H2O, it is 310.7 gram per mole. Okay, so given mass of this compound, it is given 30 gram. Here it is given, divided by molar mass. Okay, so by this way you can solve the moles. Then down what you will keep? Volume of solution. How much volume of solution it is given? 4.3 liter. Okay, so molarity you can get. So it is very easy numerical, you can solve. Now next numerical, it is the second part. Again you have to solve the molarity here. Okay, molarity. So how you can solve? 30 ml of 0.5 molarity H2SO4 diluted to 500 ml. Okay, this statement it is given to you. Whenever this type of question it is asked for dilution. Okay, suppose you have already made the solution of 0.5 molarity, but how much volume you have taken? 30 ml. But if you will dilute it by adding some water, then different molarity you will get. Okay, that molarity you have to solve. Okay, so how much it has diluted means how much volume it has, up to which it has diluted, it is up to 500 ml. So for this it is very easy method. You can use this formula, M1V1 is equal to M2V2. Okay, by this way you can solve. So molarity of first solution, it is given 0.5. Volume, how much given? It is 30 ml, is equal to molarity you have to find out of solution after dilution. Okay, how much volume up to which you have to dilute? 500. Okay, this. So M2 you can get 0.5 multiply 30 divided by 500. Okay, so by this way you can get the answer, and the answer will be 0.03 molarity. Okay, this is the alternate method. I think it is more easy method, so you can use this method and easily solve the numerical. Now next numerical, it is calculate the mass of urea required in making 2.5 kilogram of 0.25 molar aqueous solution. Actually this question it is little difficult. Okay, but you can do very easily. First you have to know about this statement, means what it want to ask. Okay, what this question is actually saying. Okay, so you can see here 0.25 molar aqueous solution. What is the meaning of this? Actually the meaning is 0.25 molar solution of urea, because it is urea taken. How much moles present? 0.25 moles of urea in 1000 gram of solvent. Why not taken here solution? Because it is given here 0.25 molar, and molar means you have made this solution in pure solvent. Okay, and how much solvent you have taken, 1000 gram. Okay, whenever molal it is given, it means you have to solve in a solvent. Okay, in 1000 gram of solvent. So actually this is the value of molality. So you have to convert this into solution because it is given in solvent, so you have to convert this into solution. Then only you can solve now in 2.5 kilogram of solution. How much mass of urea present in 2.5 kilogram of solution? So first you have to convert this molal into a solution. Okay, so how you can convert? If it is given 0.25 moles, as you know, moles is equal to given mass by molar mass. If you want to solve the given mass of the solute, then moles into molar mass you have to multiply, then you can solve the given mass. So this only we have done here. Mass, it is equal to moles into molar mass. You will get the value of mass of urea, that is 15 gram. Okay, and mass of solvent, it is already given 1000 gram according to the statement we have gone. Okay, so now total mass of solution, how much it is? 100 gram of solvent plus 15 gram of solute. You will get 1.015 kilogram. So now you have converted this molal into a solution. You have got the value in solution. So how much solution present here? 1.015 kilogram, which contain how much gram of the urea? How much gram it is present? 15 gram. Okay, we have solved now this much quantity of solution contain 15 gram of urea. Okay, so now you can apply the unitary method. How you can solve by unitary method? 1.015 kilogram contain 15 gram. Okay, then 2.5 kilogram contain how much? 15 divided by 1.015 into 2.5. Okay, so this is the unitary method that you are doing in junior classes. Okay, then you will get the answer. How much quantity it is? 37 gram urea. Okay, so you can look here again. It is little difficult question, but not as much. Okay, so again I will explain you. 0.25 molar equals solution, it is given. Actually this value it is given in solvent, so you have to first convert this into a solution. Okay, how you can convert? 0.25 molar means you have given the moles, convert this into a mass. Okay, because you can add mass with mass only. Mass of solvent given, mass of solute you can solve from there. So mass of solution you can get. Now you have got the value in solution. Okay, so after this you can use the unitary method. Okay, so next question also you can see here, but this question you can try yourself. Okay, in next lecture we will do this numerical. Thank you and have a nice day.